David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's video covers probability within the context of using Venn diagrams to show sample space. Before we jump in, let me just remind you, sample space is the set of all possible outcomes from a probability question or a probability experiment. So for example, if you roll a die, the sample space is the numbers 1, 2, 3, 4, 5, and 6, because those are all the possible outcomes that come from that experiment. So let's get started. Here's our example. We have 100 students total. 40 take biology, 36 take art, and 12 biology students also take art. So what we're going to do is we're going to show this situation with a Venn diagram, because it's going to be super handy for answering questions about, say, we pick a person at random. What are the chances they take both biology and art? What are the chances they take just biology, etc.? Okay, so your first step in making a Venn diagram is to draw a rectangle representing the universal set. So I'm just going to draw my nice big rectangle. And the way our book does it is they use a little lowercase u to show universal set. So all the possible outcomes of our experiment are in this rectangle. Okay, now we have two things we're tracking. We have biology and art. So I'm going to make two circles. I'm going to make them overlap. And we'll call this one biology, and we'll call that one art. Now we're going to be able to put numbers inside all of these circles, and we can use a little bit of math with the numbers they're given, and we can populate this Venn diagram completely. So take a look at your numbers and see if you can figure out, there's some numbers we could put on here right away. There's some that we have to do a little bit of calculating to find. All right, so the key to getting into this is this number here. 12 biology students also take art. So I can put 12 here in the intersection between these two sets. So 12 of the total that are in the biology circle, 12 of those take art. And it's also true then that 12 of the people that are in the art circle also take biology. So that gets us started. So now I want you to pause the video and figure out how many biology students don't take art. In other words, what number goes there, and what number of the art students don't take biology. So give that a shot. Let's see how you did. So we know there's 40 total that take biology. If 12 of them are here also taking art, then 40 minus 12 is the remainder of my biology students. So that's 28 there, and it's important to check. The biology circle needs to add up to 40, which indeed it does. We use the same reasoning to get 24 for art, because 36 take art, but if 12 of them are also taking biology, that leaves 24 there for taking art only. Now we're not done. There's one more number that needs to go on this Venn diagram. Please pause the video and see if you can figure that one out. All right, that's 36 that goes out here. These students are part of our 100. We can't ignore them, but they don't take biology or art. So we have to put that number somewhere in our Venn diagram. So now we can see we have a total of 100. All four of these numbers add up to 100, which is supposed to be. We've got to track all of our students in our sample. All right, let's look at a little bit of notation. I've put a couple lines up here. You may have done this before, in which case you probably know what these questions are asking. So this little n is asking how many are in, and then this parentheses here is the intersection of B and A. Intersection means what's in both. Where do they intersect? And that's graphically really evident from the Venn diagram, in that the intersection is where the two circles overlap. So coming back to this notation, it's saying how many items are in the intersection of B and A, and we can just put 12 for that. Now this next one is how many items are in the union of B and A. And the union is more open. It allows anything that's either in A or B to be counted. So go ahead and pause the video and come up with that number and put it there. So the union is just this plus this plus this, which is 64. So that's the correct answer to the number of items in the union of B and A. So now let's take a look at another concept with these sets. So remember, these are sets. We're going to use them to answer some probability questions in just a minute, but right now we have the set of people that only like biology. We have the set of people that like biology and art. We have the set of the people who like art and biology, and so on. And including, we have the set of people who like neither. Okay? So a complement is the opposite of. So A here is art. So this little line means not art. So what this question is asking for is, what's the number of people who don't like art? So go ahead and use the Venn diagram to answer that. How many people in this scenario don't take art? Let's see how you did. So that's going to be, I spelled it out with a few steps. You could probably do it in your head, but we have 100 total, and we need to back out the people that are inside the art circle. So we're going to subtract our 24 and our 12. You could go right from here because these are the people that take art. So what I did is I took my 100, I subtracted out my 36, and I got 64. So that's the number of people who don't take art, or the complement of set A in this case, which is art. Okay, now do the same thing for the complement of B. Pause the video and come back. Okay, I started with my 100, that's everybody, 100, and I basically just went right to here. I subtracted the 40 who take biology, and so this is the complement of B, the people who don't take bio, and that would be 60. All right, so now let's go do some probability using our Venn diagram. I've put up two questions for you. What is the probability that a randomly selected person is in group A, in that they take art? So what's that probability? And then I want you to go ahead and do the probability of a randomly selected person who doesn't take art. So go ahead, pause the video and come up with those two calculations. Okay, let's see how you did. So the probability that somebody takes art, a randomly selected person, is just going to be the 36 who take art over the universal set, or 100. So that's the probability that they take art. I'm going to reduce that down to 9 over 25. Now the probability that they don't take art, i.e. the complement of A, here, that's just going to be all the people that don't take art. So I'm going to use my Venn to do that. I've got my 36 here and my 28. I combine them together. That gives me 64 over 100, which reduces down to 16 over 25. Now there's something interesting going on here. I want you to take a look at those results and see if you can figure that out. So check it out. If I add them both together, the probability of A and the probability of the complement of A, I'm going to get 9 over 25 plus 16 over 25, which is 25 over 25, which is just 1. And so this brings out an important concept. The probability of an event and the probability of it not happening, when you add those together, you're going to get 1. Okay, so the probability of an event and the probability of its complement, if you add them together, it gives you 1. Let's do another one. So here's another scenario from scratch. The first step I want you to do is make a Venn diagram. So here we go. We've got 50 people, 29 like fish, 38 like chips, and 9 like neither. Now this one's a little tricky. It's a little different than that last one. But I want you to pause the video, draw your rectangle for your universal set, make your 2 circles, one for fish, one for chips, and figure out how to put the correct numbers in each spot. All right, so from the information, I can put 9 right here in my Venn diagram. Of course, I drew my rectangle for the universal set. I labeled my 2 regions, fish. There's the intersection. People like both fish and chips. And then there's the zone for chips only. Okay, so now we still need to figure out what goes in each of the 3 regions. And here's my trick for doing it. I'm going to label each one of these with a letter, A, B, and C. So A is fish only, B is fish and chips, C is chips only. And we know that there are 41 people that fit within these 3 regions because we have 9 outside from 50 total. So we know that A plus B plus C equals 41. Now that's a hint. If you'd like, pause the video and see if you can figure out what goes in for C, because you can do that now. So A plus B is 29. That's the total of people that like fish. Some of them like chips also, so we can't yet populate those numbers. But we do know that there's 29 people in this circle. If there's 41 in all three, then that leaves 41 minus 29 for C. So C is 12. So I can populate that with my 12. Now I can finish up by populating these two reasons. Pause the video and do that. All right, so now I know that there's 3 people that like fish only. There are 26 people that like both fish and chips. And then there are 12 people that like chips only. And then of course, going all the way back, we have 9 that don't like any of them. Okay, before we move on, there's one check you can do to make sure you've done all your numbers correctly. If you remember that check, pause the video and do that. So our universal set is all 50 people. So if we've done all these numbers correctly, they need to add up to 50. So I went ahead and did that, and yes, indeed, they do equal 50, so we're good to go. Now, let's answer some probability questions. Okay, I've posed 3 questions for you. I'm going to want you to pause the video, use a Venn diagram, and come up with those probabilities. You can list them as fractions if you like for now. So, what's the probability that a randomly selected person out of our total of 50 likes chips? What is the probability that our random selected person likes fish and chips? And finally, the more complicated one, what's the probability that the randomly selected person likes fish but not chips? So I've used the intersection notation. That means that they have to both like fish and not like chips to be counted in this probability answer. All right, let's see how you did. So probability of chips, that's super straightforward. That's just everybody that likes chips. We don't really need the Venn to answer that. We just know right out of the gate that there are 38 people that like chips out of 50. So 38 out of 50. I did reduce that to 19 out of 25. Now that could be on a paper 1 question. That is a non-calculator question. So you would need to reduce that fraction down. Now, probability of fish and chips, that's the intersection of both the people who like fish and chips. So that would be this number here, the 26 out of 50, reduced down to 13 out of 25. So that's that one. Now this one is the intersection of the people that like fish but don't like chips. So that would have to be just this 3. These people like fish, but they also like chips, so they can't be counted. So that one's just 3 out of 50. I want to pause for a sec and drill in to the definitions of union and intersection, just because they're a little bit confusing. I think the words actually can lead you astray. So let's take a look. So a union, which is our U symbol, it stands for or. So if you did union, it can be the item counts if it's in one or the other one. It doesn't have to be in both, it just has to be in one or the other. So fish or chips is the union of people that like fish or chips. So any number, any one of these guys would count. So we would have, if you had the probability of fish or chips, it would be all 41 of these over 50. Now, intersection with the N, the upside down U, means and it's less inclusive. In order for it to count, the union of people who like fish and chips, they have to like both. And so in this case, that would just be the 26 out of 50. And that would be this question that we answered there. So just pay attention to the difference between your unions and your intersections.
Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.